Okay, now that we got a machine learning workspace and we're in Azure Machine Learning Studio, we can go ahead and create an experiment. Of course, the first thing we're going to need is some data. There's a number of sample data sets that are inside Azure Machine Learning Studio, which are great for exploring and playing. But if you're at something like a hackathon or trying to do your own machine learning, you're going to probably need to upload your own data. So a lot of times the data you want to upload is maybe in something like a CSV file, a text file that you want to read in. So the first thing you're probably going to need to do is select data sets and select new. You can see there's a number here, and just say you're selecting from a local file, go browse, select the file that you want to upload. So I've got a few data sets that I've been playing around with, some stuff on breast cancer data, some stuff on SPCA data, and just specify whether or not your file has a header with the column names, and then just select the check mark to stop uploading that data. And that'll start uploading the data, and you can see over here that there's the little green progress bar indicating that it's uploading that new file for me. Now, once that file is loaded, then you can go and start a new experiment using that data. So you go to experiments and you create a new experiment. And when you create a new experiment, you just say new experiment blank. And that'll bring you to this wonderful window where you can go ahead and start working on an experiment. And you can actually see here, it didn't actually take that long to upload my data. It's already completed the upload. Once it's uploaded that data, you get this little neat preview here. I'm just going to get rid of that by selecting this little mini map and hiding that. It gives me a little more room. And if you expand data sets, if you select samples, that's where all the sample data sets are. That there's lots of sample experiments and things out there to help you learn. But the data sets you upload will be here under My Data Sets. So there's that breast cancer data. And if I want to use that data, I would just drag and drop that over here, drop it onto the surface, and I'm off and running. Now, rather than you sitting here watching me creating an experiment completely from scratch, I'd actually like to walk you through a completed experiment so I can talk a little bit more about what's happening in the experiment, though I promise you'll still be able to create your own when you're done. So I'm actually going to go to my experiments here, and I'm not going to save the changes to this one. I've been working with some interesting data from the SPCA that helps predict whether or not an animal is going to be adopted so that they can find ways to maybe come up with promotions and things to help animals who might not be as easily adopted. I got this data from Kaggle. This is a neat website, kaggle.com. It's a neat location for playing around with data science. There's a lot of competitions here and a lot of organizations that make their data sets available. So if I just select data sets, there's a number of data sets here that you can download, which are great for just learning machine learning or to actually try and help solve some real problems. So there's all sorts of interesting ones in here. The iris is a classic learning algorithm that's a learning data set that we use to practice classification in machine learning. So you'll find the famous classic data sets here, as well as a lot of other real world data to help you practice real world machine learning so you can really build those skills. So that's actually where I got this SPCA data set. So what I have here is a very simple experiment that I've created, and I uploaded the SPCA data file, just a CSV file. And if we zoom in a little bit there you can see I've dragged over this data set from my data set. So I just dragged this right over here. Now, one of the most important things you want to do when doing machine learning is get to know the data you're working with. So one of the great features of this Machine Learning Studio tool is the way you can just right-click on the data set once it's loaded, and you can choose to visualize it. Now, if you've been working with the data, you may know it already, but if it's something you've uploaded, if you've uploaded from somewhere like a Kaggle or a website, you may find some documentation that describes the data set. Do take the time to read that. It's going to help you. The better you understand the data, the better it's going to help you run very effective experiments. But this is still useful as well. I can quickly glance and see I've got different animal IDs, names of the different animals who were at the SPCA, when they were brought in, what the outcome was. Was it returned to an owner, or was it euthanasia, adoption, or transfer? And as you look at this, you might be going, well, what are the different possible outcomes? Well, one of the neat things about the tool is if you select one of these columns, you can actually see that there's 5 different unique values for it. So you can sort of see that 5 different unique values. And if you scroll down, you even get a histogram that shows you all the different values and how many you had of the different values. So you can see that most of them end up being adopted or transferred. Luckily, the number who pass away is actually quite low, so that's great. But you can get a sense of the data as you take a look around, and look at the two different types of animals. So here we're only looking at cats and dogs. I know my local SPCA has parrots and rabbits and all sorts of things. So this data set is only cats and dogs. So it's great to just take a minute or two, look at the data, and get a feel for the types of data that you've got in the data set. So love that right-click, data set, visualize, that allows me to get that view of the data. Now, we're using machine learning to try and identify what causes an animal to be adopted or not adopted. But we know that some of those columns are more meaningful than others. I don't think the animal ID determines whether or not an animal is going to be adopted. So if I can take out some of those columns when I run my experiment and tell the machine learning studio to ignore them when it's trying to create a model for the data, that's going to take away some noise that might distract from the most important data. So if there are columns that I know have no impact on adoption, I want to take those columns out. So that's why I added this select columns option. So I just type select columns over here in the search bar, you drag over select columns in data set, and you can see I've dragged it over and added it to my data set. And after you drag that to your experiment, you select the column selector over here, and you select which columns you think are the ones that are going to have the most impact on whether or not an animal is adopted. And these are the ones that will be considered when your machine learning experiment runs and tries to create a model to represent and predict outcomes of future animals who come into the shelter. So you can see I've decided I don't think the animal ID's name, the name of the animal's ID, when they arrived, though that might be a factor. Maybe I should have that in there. You know, maybe animals who come in January get adopted faster than animals who arrive in June. And outcome subtype, I didn't think that was going to be a big factor either. Now, you don't have to pick the same columns I do. This is why it's an experiment. If you're not happy with results you get when you run your experiments and you're not getting high enough accuracy on your predictions, one of the things you might do is come back here and change which columns you select. But this is what I'm using as a starting point. So those are the columns I've selected. And then the next thing we always do when we do a machine learning experiment is we split up our data. So I've dragged over a split data task. Again, I just typed in split data over here and dragged that task over. So you just type split data and drag that task onto your experiment. And when you select it on the right-hand side, you'll see what it does is it splits the data up in two. There's different ways to split it up, and what I'm doing in this particular case is I want to put some of my data aside for testing. Because that way, once my machine learning experiment is completed, and I want to actually check and see if the model that's going to make predictions is accurate or not, how do I know if it's going to be accurate? So the experiment's going to create a model that tries to predict outcomes for future animals. But I have no idea if it's a good model or a terrible model. How do I know if a computer did a good job? So what I do is I take some of the data and I split it, put it aside so I can use it for testing, where I have records with known outcomes. I know if they got adopted or not. And then I'm going to use that as test data on the completed model and say, hey, run your model against these records and see if what you predict is what actually happened. So what I've done here is I've said take 0.8, so 80% of the rows, and that will be sent down path number 1, results data set 1. And 20% of the data will go down here through results data set 2. So you usually will send about 70 to 80% of the data will be used to train the model, and we'll save 20 to 30% typically for testing. You can decide on the exact split. So I've saved 20% of the data here by using 0.8 of the records, or 80% of the records will go down path 1. So that's what the split data does. Then you're ready to actually train your model. Ask the machine learning studio to go ahead and create a mathematical model that can predict outcomes for future animals. When you do that, the first thing you have to tell it is, what is it you want it to predict? In this case, I want it to predict whether an animal is going to be adopted or not, or will it get transferred to another location, or is it possible to get returned to its owner? I want to figure that out. So I have to select the column selector here after I select train model, and I specify that I'm trying to predict the column outcome type, because that's the column that tells me what happened with the animal in my data set. So it's really important that you specify what column you want the model to predict. Then you have to pick a way of predicting it. Now, in this case, I'm doing what's called classification. We saw there's 5 possible outcomes for an animal when they come into the SPCA. They could be transferred, returned to owner, they could be adopted, they could pass away, or they might go down for be euthanized. So I have to handle multiple situations. That's what we call a classification situation. So if you search for a multi-class, you will see a whole bunch of pre-built algorithms that are designed to try and make predictions for multi-class or classification models. So anytime you're trying to do a prediction when the result might be one of multiple different values, but they're very fixed values. You're not trying to predict a number from 1 to 100 here. You're not trying to predict a value. You're trying to predict which category something falls into. We do that, call that classification. So I can pick any one of these models and algorithms and drag those over and connect that to my trained model. So I'm saying, here's the data, here is the model I want you to use to create your formula to make predictions. And now it can go ahead and actually create a mathematical formula to try and figure out which factors determine what an outcome is going to be so I can make predictions. So I've selected multi-class logistic regression. Are there other ones you can choose from? Sure. And in fact, you might want to look up, if you go to a useful little tool, if you search for Azure Machine Learning Cheat Sheet, this is a wonderful little tool. So under azuremicrosoft.com, there is a nice little PDF file you can download that actually gives you a flow chart that helps you pick the different algorithms and models so you can figure out which one's the best one to use. So if you've never done machine learning before, this can be a good starting place to help you figure out which model I use. So it'll actually give you, say, what are you trying to predict? I'm trying to predict a category, and the category could be one of 3 or more. So I want to go with multi-class classification. Then it explains that multi-class neural network has high accuracy but takes longer to run, whereas multi-class decision forest is high accuracy but it trains fast, which means it won't take as long to run the experiment. So this is a great little tool, if you haven't used this before, to help you figure out which of these 4 or 5 different classification models to choose from. So I've picked multi-class logistic regression. If I'm not happy with the accuracy of my results, maybe I'll try a different model. Once these statements have executed, then I'm ready to score the model. This is actually my testing stage, because once that trained model task is done, my experiment's completed, and what I now have is some sort of mathematical formula that weights the different factors that I've passed in to try and predict what causes a particular outcome, so I can make predictions. So you'll notice that test data, the split data here, that 20% of the data output I have testing, I've dragged it down to a score model. So the score model is going to do my testing for me. So I take my mathematical model, connect that to score model, and I take my test data, and that's now going to take my test data, run it against the formula, see if what the machine learning model predicts would happen is what actually happened for the animals with known outcomes. Once that's done, I drag over an evaluate model task, and that's simply going to take my results and put it into a nice report so that I understand what it's telling me. So once you've done that, you simply choose to run your experiment once you've got everything connected. And after you run your experiment, you'll see green check marks on everything. That means everything went well. It may take 15, 20, 40, 50 minutes. It may take 2 hours to run this experiment, so don't panic if it takes more than 5 minutes. The more data you have, the longer it takes, and certain models take longer to run than others. But once it is done, you see those green check marks, you can right-click on Evaluate Model, go to Evaluation Results, and choose Visualize. This is going to bring up my results to tell me how the testing went on my model. Is my model good? And my overall accuracy, wow, 0.35, that's not great. That's 35% or 36%, 35.8. My average accuracy is 78.6. It's a little better. But I find these numbers don't tell the full story. What's really interesting is to go down to what we call the confusion matrix down below. And what this does is it tells me what was the predicted outcome for a record versus the actual outcome. Because remember, I ran test data where I saved 20% of my records, where I actually know what happened to the animal. And I said, hey, try to predict what would have happened with this record. And then I compare it to what actually happened. And this is the results I get back. So you can see that when my model predicted the animal would be adopted, 55.7% of the time, it was right. But 1.1% of the time, the animal that predicted would be adopted, turns out it was actually euthanized. 14% of the time, it was returned to the owner. 28%, almost 29% of the time, it was actually transferred, and 0.1% of the time, apparently there was some missing data there. When I predicted it died, it didn't ever actually predict that any animals would die. It accurately predicted that 2.3% of the animals would be euthanized. So when it made a prediction, that on those particular cases, when it predicted euthanize, it turns out 57% of those animals were actually adopted. And so 12.4% were returned to owner and 28.3% were transferred. So what you want to see is numbers as big as possible in these boxes across the diagonal. The bigger the numbers are, that means tells you how many times it predicted the correct value. So when I predicted it would be transferred, I was right 31.9% of the time. When I predicted it would be returned to owner, I was right 12.9% of the time. When I predicted it would be euthanized, I was only right 2.3% of the time. So you can see why that brought my accuracy down. So we want these numbers to be as big as possible. So there's clearly some room to improve this particular model. But hey, that's why we call it an experiment. So we at least have successfully run a machine learning experiment. In my next video, I'll show you some ways that maybe we could get some better accuracy.